Okay. Here, I'll get rid of the background so it's not so distracting too. Okay. So, what did we spent the last, like, I don't know, 3 days doing? Yes. Ratio. So a ratio is a fraction comparing two things. Okay. We could also write ratios as with the colon too, right? But I like the use of fractions just because everybody's scared of fractions. Okay.
I am scared of fractions.
So we just try to eliminate that fear, okay? Then I think this is a new word. A proportion is a statement that compares two ratios together. Okay? Do we have any idea what the next blank might be? By introducing an integer. Okay, that's not bad actually. Yes, we're going to introduce a question mark sign or an equal sign. An equal sign. We're able to use the proportional statement to solve for the missing information. Okay? So, now we're going to address, can everybody see that? You want me to zoom in?
You can see it on your own page.
Yeah, you can see it on your own page too. Or you can watch the video after too. Right? Bump up that watch time. Okay? So for example, if we look at the map, can everybody see the map on their page? Okay, do we see, this is on all maps, whether or not you know it. Okay, if you zoom in there, what it's saying is 1 centimeter is equal to 400 kilometers, right?
That's a lot.
It is a lot. Well, the world's big, right? Globe. So the scale reads, here's how the scale reads. 1 centimeter on the map represents 400 kilometers in real life. Okay? So, does everybody understand that? So if I measure 3 centimeters, or like if I just measure any distance on the map, if I want this point to this point, what I can do is measure the number of centimeters between those 2 points. If it's, I don't know, 2.5 or whatever it is, that represents something in real life. That's what the scale's telling you. Right? So that when you pull out a map and you look at how far is it from here to Toronto, and you look at the scale of the map, it should spit out something like 300 kilometers, 350 kilometers. That make sense? Okay, so there's a way to actually contextualize how far things are from a map, okay? I know some of you just came out of geography too with Mr. Compo. Okay, so hopefully you saw that in geography, okay? This actually lets us solve for things now, right? So, let's say, I'm going to erase that line because I want to do the actual line here. Okay, let's say I measure the width of this, and I say like the whole piece of land is, I measure 3 centimeters, something like that, okay? 1 centimeter, 2 centimeter, 3 centimeters. I know that the scale factor, or the scale, not the scale factor, okay? That's just from the, right here. Right? Where it says 1 centimeter is 400 kilometers, right? Now I want to figure out from that, look, let's say I could measure any distance on the map physically. That's going to be equal to, how many centimeters did I measure? 3. And I'm interested in what? How wide is the map in real life? Question mark. The important part is that we've matched up the units. See how the top goes to the top and the centimeters and centimeters? That's important. Okay? What do I have to do to figure out the bottom. How do I get from 1 to 3? What do I have to do? And remember, we don't add. There's no adding, right? What are we doing? Yeah? Times 3? George, are you going to say times 3? Okay. We're going to multiply by 3 to get to 3 centimeters. So I better do that in the bottom, too. So it's 400 times 3 is equal to what? 1,200 kilometers. Okay. Is anybody freaking out?
Nope.
Okay. It's all we've done this morning. Okay, you could kind of represent that with your tiles if you wanted to, whatever. Harry, yeah?
I know the Hot Wheels answer.
Okay, let's I'm not quite done with this yet. Have you guys ever seen this before? Have I shown you this? Therefore. So anytime you see like kind of a word problem, right? You could write these 3 dots. That represents therefore. Right? Is what it means. Therefore, the width, this is just like a concluding statement. The width of the land is 1,200 kilometers. Does that make sense? Anybody stressed? Hopefully, like we've kind of like I've laid the foundation for you guys, right? It's the same question as that. Just trying to figure out how many claps there are in 60 seconds, right? Just finding what we call the scale factor. What's the scale factor in this question? Do we know what the scale factor is? Yes? Say that again? Yeah, it's what you're multiplying by. Or dividing, because we saw one this morning where we divided, right? So what's the number that we're multiplying or dividing by in this question? 3. So this is what we call a scale factor of 3. It's scaling up by a factor of 3. It's getting bigger. That's how we got 1,200. That make sense? Okay. Yes, sir. I haven't even read it yet. Converso Class 8 there. I'll read it if you want. Or do you want to read it?
Sure.
Okay, let everybody catch up. There's still some people writing. Okay. We don't want to move too fast. We want to make sure everybody's okay.
It's not called a Hot Wheels for no reason. Only because they go fast.
You should be the marketer for Hot Wheels. Okay. Okay, here's what we got in the second question. Okay, I don't know if anybody collects these. I used to collect these as a kid. Do you?
Yeah.
I have like basically the entire 2006 collection. Fun fact.
Pretty sure I had that car at one point.
No, like the entire Hot Wheels collection. There's like 30 or 40 cars. I have the entire like 2005, 2006. This is what I did as a kid. Okay. What do you notice on virtually every like Hot Wheels package? What's that?
It shows an image of the car.
Oh, it shows the image of the car and then the what? Sorry.
There's a little blister.
Yeah, you see the actual car, like it's clear, and
Says the series down the side.
it tells you the name of it, like what kind of car it is, what year it's from. But there's also something else on there. The age, sorry? Is that what you said? Yeah. There's something else. It might not explicit. It doesn't say explicitly on the front, but on the back,
What scale it is?
what scale it is
1/64.
is 1/64 scale. So what that means is like it's 1/64th the size of the real life car. Okay? So our question is, because you could like put a ruler up, right, and measure the car in centimeters, right? And let's say it's 7 centimeters. Our question is, how big is it in real life? I know you know the answer. We gotta figure it out. Okay. Here's what we gotta figure out. We know that the car is 1/64th the size. Okay. This one's a little trickier because we're not necessarily, the units are the same, but we'll say in real life. So 164 in real. How's that? Is everybody okay? So every 1 centimeter that you measure on the Hot Wheel, that represents 64 centimeters on the real one. Okay, does that make sense? So, how many centimeters did I say we measured this car to be?
7.
Okay, everybody see where the 7 centimeters came from? 7 centimeters, the real car, right, from here to here. So let's just write it as a ratio and create it into a question that we've seen 10 times today, and that's it. Okay. The Hot Wheels car measures 7 centimeters. Our question is,
What is that scale in real life?
what is that scale in real life?
1 centimeter equals 64 in the real one, then 7 times 64 equals 448, and 448 centimeters in the feet is 14.
Feet? You did feet?
I did feet.
What kind of crazy country you living in doing things in feet?
America.
America.
I was working miles per hour as well.
Yeah, don't do that. Actually, that car's in miles per hour. It doesn't do kilometers per hour. So as I'm driving it, I have to figure out what my speed is in kilometers per hour.
Conversion rate.
I have to do it in my head. And it's not marked either. Like, you know, on like the normal cars now, they've got 2 separate dials. It's not marked. It's all in miles.
You just make like a little paper sheet.
No, I like put the car in park and I like do my proportions calculation with speed.
I wonder if I was speeding the whole way.
I wonder if I was speeding the whole way home. Okay. What do we have to do? What's my scale factor?
64?
Not quite.
Or,
No, scale factor you're always relating. Nope, that's just the units.
oh yeah.
Scale factor is what to what?
Oh,
What
1
do
to
I-
7
So what do I have to do?
multiply.
By 7, right? So my scale factor is 7. So that must mean if I multiply by 7 in the top, what am I going to have to do in the bottom?
Multiply by 7.
Multiply by 7. Okay, so what is 64 times 7?
448.
So 448 centimeters. What is that?
Well, I didn't do meters.
Okay.
I converted.
400 and, let's take a look here. You tell me if this is reasonable, see if this makes sense.
It's 4.48 meters.
I don't even know if the room's big enough to fit the car up here. Good thing I don't try and park it up here. Okay. There's one, that's, okay, how many centimeters are in a meter? 100. So how many of these sticks should I expect to see on the ground?
4.5.
4 and a little bit, right? Because it's 448.
448.
4.5. You want me to actually use all 4?
Sure.
You guys can look at it on the way out of the classroom to see how big 4 meters is, 4.5 meters. Is there another one? I'm not gonna break one in half though, Mr. Honey, do that. Right?
We need that realistic representation.
And some. And some. Do we have one more? Okay.
Take this one, Mike.
Is there one on that chalkboard?
No, I used them all.
At the other end?
You can take this one, Mike.
True. Okay. So it's all the way from here. It's almost out the door. That's how big the car is.
What is the car doing?
When you come back, I'll find a picture of it in the garage and see how big it is.
You could park it in this classroom.
I could, but I can't get it through the door.
Yeah.
I don't know how we're gonna get it here.
Turn it sideways.
Turn it sideways. Then we never try to turn 4 meters this way. How are we gonna fit it through the door?
If you put it sideways, because
We'll put it through the window. I can just break down the
Never mind.
I don't think it's gonna fit through the window.
Just action movie.
if you took everything down.
Down the wall.
Okay, does that make sense?
Teleport it
When
through.
you guys come back from break, I'll show you a picture of it in the garage.
We'll
Up
break
against
this
the
wall,
window.
we'll break both windows.
You know what's gonna happen if we start messing around with that wall. This whole place is gonna fall down.
Exactly.
It's gonna be your fault.
Then no.
Yes, it is.